I build software to help understand human behavior. And one of the sources I base my research on is electricity. You see, our bodies is an ocean of electricity. Everything we do is controlled and facilitated by electrical signals running to our bodies. When we speak, when we walk, when we move, even if we're simply breathing. Well, today, we're going to be using JavaScript to witness some of this electricity in real time. So I am going to need a volunteer, and before you raise your hands, just hear me out here, okay? Just make sure you don't have a dirty mind. It helps if your head is not way too big so it can fit the headset. That being said, who's down for the challenge? Your head is too big. You. I'm just kidding, Tracy. What is your name, sir?
Dustin.
Dustin. Thank you so much, Dustin, okay? Just sit down here, please, and relax. Hat off, yes. So I'm going to let you just take a look at this first so you know what you're getting into.
Yeah, it's pretty intense. There's like spikes.
Yeah, it's going to feel a little spiky. So most of this is just plastic. There's a board, there's some cables, but you should be fine. So what I'm going to do is that I hope it fits on your head, but let's go ahead and put it, on. Okay, don't push it too much. I'm going to adjust it so it fits a little better. And it should feel a little bit more comfortable, but I'm going to make sure all of the sensors are making contact. Okay, your head is pretty decent, I'll have to say. Okay, so a little more. There you go. Okay, how are you feeling so far?
Nervous.
Okay, and you should totally be nervous. So the next thing that I'm going to do is that I'm going to plug in these earlobes. It's not a big deal, just so your head doesn't explode. And I'm going to turn it on back here. Do you mind standing up and just showing people that this is on? Yeah. You can see the blue light, right? Cool. Sit down. Get comfortable. You will look, yes. But before we get started, just so you know, we're going to get pseudo access to your brain, and I hope you have nothing to hide. Yeah. And make sure you read the fine print. Just basically make sure you don't sue me if anything happens to you. Okay, so let's get to the demo. Let's see your brainwaves, and what I'm going to do is that I am going to launch my Node app and run my command to just start visualizing, okay? Relax. Oh, that's pretty good. So you have one sensor right here that maybe on that, there's two options here, the two possible outcomes. Either your head has nothing on that side, or the sensor is not making contact. So that sensor should be number 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's see. You might not have anything in there. Give me 1 second, let's see. And that's completely fine. Like, you don't need to use 100% of your brain, you know that, right? 7, 8, 6 is this one. You know, the fact that you can speak is a miracle. So I'm going to assume there's something with the sensor. It's fine.
That's a good assumption.
Yeah, just, okay, so we're getting data. lots of data, real time, most of your head, okay? We're missing one channel, but don't worry about it. I have some tools to open it up later and see what you have in there. You're concerned? No, most likely it's just a headset, you're fine. Okay, so that's the data part. This is getting wirelessly to the app, right? And I'm going to explain everything in a little bit. Before we do that, let's just see how that looks like. By the way, I used the Angular 2 CLI for this. So thank you, Hans. Localhost. Whoa, okay. So we're getting some brainwaves right now. We're missing some channels. Contrast is not great. Can you guys see? Kind of. Yeah, any chance we can get a little bit more contrast? Okay, slightly better. All right, awesome. So you're getting some brainwaves. I don't see everything in here, but it looks pretty normal. Yeah, exactly. So what I want you to do is a couple of things. Stay relaxed, don't move at all. Can you try just clipping your jaw real quick? We're trying to capture some of the muscular activity first, and that's what you did. You did it around like 3 or 4 times. Good. Can you blink a few times? Okay, so we're getting some responses here. Awesome. So this is all I'm going to show you for now, and what I'm going to do next is go back to my presentation and just talk about what this is. So this is what I'm calling NeuroJavaScript. And what NeuroJavaScript is a combination of isomorphic JavaScript, so everything you've seen today is basically powered by JavaScript, mostly, right? From the data part here on the node side of things, and then on the client, we're using Angular and just JavaScript. There's a NeuroTech aspect. As you can see, we have a headset, which I'm going to talk about a little later. There's some data science, as you can imagine. This is pure electricity. So what does this mean, right? We need to be able to apply some machine learning and data exercises. So there's some data visualization, so we can get actual feedback of the brain. And open source, which definitely is something that is extremely important for the success of this project. And by the way, everything I've shown you here today is open source, including the headset. So let's talk about the communication. We have the headset from this right here, and via Bluetooth is connecting to a USB dongle. I'm going to show you. You can see maybe the blue and red lights here, which connects to the computer. The computer gets the data via serial port, meaning the USB, and passes it to Node. Node is able to read it from the serial port. It sends it to the web browser via WebSockets. That's high level. So the headset has a board here, which is a custom microcontroller that takes up to, I believe, 16 channels, this version. Right now we're using 8 channels, but one of them is not working. We don't know why. And we have sensors. They're actual electrodes. When you were talking about the spikiness, most of the sensors have those spikies, some spikes. The 2 up here are just flat. And from the sensors, through cables, those are getting into the board. The board is Bluetooth enabled. And this is just a little illustration of how the actual headset comes together. This is the same model that I'm using today. And it's created by a company called OpenBCI in New York. Anyone from New York in here? Okay, that's when no one is rude. Awesome. I live in New York for the past 8 years, so great. So Then we get into the dongle, which is actually part of the set. This USB dongle, I hate that word, is basically is based on Arduino, the Arduino microcontroller family. Are you guys familiar with Arduinos? Yeah, awesome, great. So in the future, this will most likely disappear because the communication could be probably be direct from Bluetooth to the computer's Bluetooth or Wi-Fi or something else, right? But right now, this Arduino is enabling a very, very high speed rate for this information that is getting to the computer. Then we get into Node. There is a Node SDK that you can actually install. It's on NPM, of course. It's all open source. And this allows for you to easily start streaming the data from Node. And it's actually very easy. All of the code that I'm using today for this demo is in GitHub. I'm going to have some resources at the end so you guys can see that stuff. And this is a sample of what you were seeing on the Node terminal, right? Even if we switch, you can still see it. Great. So what is this? This is data sample, and we're getting one data sample with the latest electricity snapshot every 4 milliseconds, which makes a 250 hertz sample rate, which is pretty good. The data at the bottom here, actually the aux data that you see, you can see that it flickers because we're getting actual accelerometer data from the headset. It was working? Maybe you're thinking harder now. Wait, almost. Keep doing that. But we're getting accelerometer data that we can actually capture the axes of the headset, X, Y, and Z. So you can use that information to do data visualizations in a more like 3D environment, which is pretty awesome. Okay, my presentation is here. So we're getting a sample every 4 milliseconds. And ultimately, it gets to the browser via WebSockets. Have you guys used WebSockets here? Yeah, pretty cool, right? So I built this app in many different, combination of technologies. The latest one proven to be the most successful has been Node, WebSockets, Angular 2, and some custom data visualizations plus some of the libraries. Some of those libraries include Plotly.js, which is a wrapper for D3 for data visualization, Smoothie for the time series, pretty much the series that I showed you earlier, 3JS for 3D data visualizations based on WebGL, Chart.js 2D charts in JavaScript, and lastly Angular 2. I'm using Angular 2 for the change detection and to control the whole application lifecycle. And I'm going to show you some examples of components using some of the lifecycle hooks to make all of this happen. Great. So what we saw was something kind of like this. This is with simulated data. And I'm using Angular 2 in a Smoothie. And one of the things that I want to show you is how easy it is in Angular to use the dependencies. And at the end of the day, Smoothie is based on Canvas technology, right? So if you see here, the most important part is that we have a Canvas element, right? And we are referencing that. But let me show you the component metadata first. We have a selector for our component. How many of you are using Angular 2 so far? All right, pretty cool. Are you guys excited about version 2 being final? Awesome. I was like in the front row when they announced it. It was pretty awesome. There were like balloons and cupcakes. You guys know what I'm talking about. So what do we have in here? We have our component metadata. We have our template, very simplified. And then we have some dependency injection. The major dependencies that I'm using here is the element reference from the Angular API, Angular Core API. I have a chart service that I created custom as an injectable just to get some chart related data, and some constants. Since I'm using sockets, I have my socket IO client, and I'm making an instance. I'm creating an instance right here based on the socket URL. And then I have some, let's say, data containers, some arrays, and then some data structures that are going to hold the actual time series data that is going to be passed into the canvas. So we have the smoothie chart, and then we have an array with basically 8 arrays, each one mapping to its own time series. So those 8 lines, for each one of those, you're going to get 1 line. So the first thing that I'm doing is that I'm using the ng on init component lifecycle hook. So as soon as the component is ready and all the data binding has been done, I'm calling a function that I'm going to show you that adds all the time series to the canvas, but I'm also listening to the socket event. And the callback for this socket event here is updating my major data structures. The amplitudes are the values that you can see. So let me show you here. These are the amplitudes right here, and they're updating, right? We have the timeline, which are the lines themselves, and then each time we receive an event, and please have in mind that what we're doing on the node side is that we are creating a data buffer because we don't want to send a socket event each 4 milliseconds to the client. We try that, it overwhelmed the client. So we are having a buffer of, let's say, 1632 samples. We're doing some data manipulation, and then we're sending one single event with all that data for the front end to be to visualize that. ng after view init is another Angular hook of the component that ensures that the template, the view, is ready, and we're using smoothies time series class, and we're calling a stream2 method that basically maps the time series to the canvas element. So when you see this view, native element, query selector, time series, this is just a reference to the canvas element. There are multiple ways of referencing that element from the Angular component. Add time series lines adds the first set of lines to start accepting data. For each one of the lines, is adding the line based on the time series class, and is adding a color. So you do this one time. This is the function that I was showing you earlier here. And then we append. So each time we get a socket event from the server, we're calling this function, which is adding the new value in real time. And as you can see here, we get the current time and the amplitude, which is the actual value. Something that is very important for performance purposes is removing the event listener once the component has been destroyed. And that is exactly what ng on destroy does. Otherwise, you have some socket events lingering, they can add up and they can hurt your performance. The part that shows the amplitude that I show you is just a simple ng4 in Angular 2. If you're familiar with Angular 1, you can kind of see the similarity in the syntax. And some ng style to color the amplitude number the same as the line, just to make that visual reference there. Ultimately, we're using Angular 2's data binding to show the amplitude. Same thing for the timeline at the very bottom. This is just a simple ng4 displaying the time. Great, so I wanted to pretty much tell you about this project. The first time I started using this, I wanted to quickly start controlling other people's with this headset, you know. And I was like, well, I'm way over my head. Before I can actually use it, I need to understand it and visualize it. So this is the first phase, visualization. This is what I'm showing you today. The second phase is going to be experimentation. I did a little experiment to kind of try to see, to detect hunger in people. And I'm going to resume working on that. I was not successful. I got super hungry and grumpy, and I didn't want to code. So I put that into a pause. But ultimately, what we really want is interpretation, right? Being able to map electrical signal to actual human commands, right? Being able to control a user interface, be able to control a wheelchair, things like that. Do things like this. So I invite you to get involved and to check out the meetup page and also the GitHub that presents all of this code is open source. I invite you to the OpenBCI community where you can see what other people are doing, JavaScript or not. We're a small team based in here, based in the Bay Area in New York. So some software engineers, some recently graduated PhD for neurotechnology. And we're very excited to kind of like use our current skills as software engineers to do more things or very minimal things. Hopefully contribute to psychology, to to the medical field, and to many, many other fields that could use more help when it comes to understanding the human brain. So thank you for being here, and let me know if you have any questions. I'm around.
Thank you, Alex.